the time. There are many, many other stages that you can think of, but I want to introduce a few that are of special interest. First, I want to talk about indirect feedback. Indirect feedback, as I told you in the introduction, is, let's say, inferior to direct feedback. Because we are not sensing the quantity that we want, or not comparing with the quantity that we want. A nice example is here a indirect feedback current amplifier. You see here the current source, and I'm sensing the feedback is coming from another 2-port, from the upper one. And it's driven, it's a copy. It could be the same transistor, for example. It's a copy of the other one. So if you drive it under certain conditions and load it under the same conditions, there will be exactly the same transfer in this thing. Now look what we are going to do. I'm going to replace both blocks ABCD with one transistor, and then I say, well, let's keep of the upper transistor. You see, is in the loop. The upper ABCD block is in the feedback loop together with another. The lower one is not in the feedback loop. It's in the transfer to the output, but not in the feedback. So I could also say skip the null or use the other transistor as the one and only controller, and then you get this. If you do that and you make it unity gain, so Z1 will be 0 and Z2 will be infinite. Then you have this, and if you draw it in another way, you have the current mirror. So the current mirror can be seen as an indirect feedback current amplifier in which we are not directly sensing the load current, but we are sensing a copy of it, and the feedback is in the left transistor of it. But of course, you can put more transistors in the loop and get a better one. But still, it will never be as good as a direct feedback current amplifier, because we are not sensing the load current, which means that the output impedance is not increased by negative feedback. That is what we can already say just without doing calculations. So here we can, let's say, later we can make calculations, check our assumptions, but it's very important that we have simple ways of reasoning what the properties of such stages will be. So indirect current sensing feedback has no influence on the output impedance. Another one is the indirect feedback voltage amplifier. It's a voltage mirror. It's not so familiar as the current mirror, because the current mirror is very handy for all kinds of biasing solutions in amplifiers, and the voltage mirror is not so popular, but it's still there. Here we have indirect comparison. We have 2 blocks, A, B, C, D, and I do exactly the same. There's one loop, the right block together with a nuller, and if 2 blocks with the parameters A, B, C, D are equal, then the gain should be nicely defined by Z1 and Z2. Now, do again the same thing, make the upper transistor, make this, say, well, we have already gained the second transistor, and take a complementary device for this, and you can this schematic. And this is then a unity gain voltage mirror. And of course, since now you can see that this element is basically, the upper element is now a 2-terminal element, you can also use the complementary version of it, which is N-type again, but flip the terminals. Because flipping the terminals and make it into complementary is actually doing nothing. That is what we learned in the chapter about biasing, balancing. And here you have. This is a voltage mirror as people know it. And if you stack 5 transistors on top of each other here, you have a voltage gain of 5. So indirect voltage comparison, the feedback has no influence on the input impedance. That is clear. And there's still much more. And now I will go fast. You can do anti-series connection of stages. This is the stage that did B only with a resistor. You place them anti-series, you get a balanced single stage feedback amplifier. You can do complementary connection of feedback stages, and here you have a complementary drain follower. So all modifications can be explained from application of negative feedback and application of balancing. You can do multi-loop feedback, signal stages. And here you have positive feedback, fixing B and C. Here A and D, where A is unity. Here A and D, where D is unity. But you should be able to invent them now all yourselves. And there is still more. Combinations of all kinds of techniques that you can use to generate your stages that you want, because you know what changes are the result of applying techniques. And still, there is even more at the end that we did not yet discuss. And therefore, I hope you keep following us.